Hello again everyone, welcome back to PTED Chemistry channel. So my name is Mr. On, and in this lectorial video, and we'll continue this tutorial on atomic structure and the periodic table. And since this is a lecture tutorial, which I have abbreviated as lectorial, this series will look at going through the learning objective as outlined by the syllabus. This is the Cambridge International Chemistry O-Level 5070. This is a pure chemistry component, but atomic structure in reality is common whether you're doing the core or the extended bit of the IGCSE chemistry curriculum, as well as any 14 to 16 years old chemistry all around the world. Wherever you are, you would have done, or you have completed atomic structure regardless. So this bit of atomic structures continues on what I had done previously, which is to do with proton number, mass number, all those nucleon number, atomic number, all those terminologies. And in this tutorial video, I'll go through how we fill in the electrons into the energy levels, or what we call them electron shells, because the electrons are found in orbiting around the nucleus in this specific region of spaces where the electrons are most likely to reside. They are called energy levels or electron shells, and as such they will have like different electrons filling in the first shell, the second shell, the third shell, and so on and so forth. And we need to determine, so the syllabus says you should be able to determine the electronic configuration. So electronic configuration is to do with how the electrons fill in the electron shells, and the electron shells have a particular definition on its own, but electronic configuration is defined as the way or how electrons fill in the respective electron shells. And this is not only for the elements, of course we'll start from the elements, but also the ions. So this is the first time we have heard of this word ions. If you watch the previous video on elements, compound, and mixtures, we have encountered this term ions, and I'll talk more about it in terms of their proton number, as well as counting the number of electrons. They are related to the previous subtopic that I went through. 2.2.6 is a very simple one because it's stating. So this is determined and this is stating. So stating is just that you need to know the group 8. This is Roman numeral for group 8. They are the noble gases. They have a full outer shell, or we say full valence shell. So valence shell is also the other word for outermost shell. And if we refer to the periodic table, which I have here, this is group 8. That is all the noble gas here. So all the noble gas, okay? Helium, neon, argon, krypton, xenon, and radon. They all have 8 electrons in the outer shells. That is because they are in group 8. Alright, so 8 electrons in the outer shell. Or we will say it has 8 valence electrons. Okay? So going back to that, so it says that the number of outer shell electrons, the number of valence electron, is equal to the group number in group 1 all the way to group 7. And of course for group 8, you will have 8 outer shell electrons. In the case of helium, is special. Alright, in the case of helium, is special because, well, helium only has 2 electrons because it has only got 2 protons, as we will have covered in the previous lesson. As part of atomic structure, if you have 2 protons and the atom is uncharged, then you would definitely have only 2 electrons as well. Okay, but the other noble gases, they will have fully filled outermost shell. Okay, not necessarily add electrons in the outer shell. So perhaps I should really revise what I said, not really add electron in the outer shell, but fully fill outer shell as stated in the syllabus, because this is 2 electrons in the outer shell, this is 8 electrons in the outer shell, this is 8 electrons in the outer shell as well, but all of them have a fully filled valence shell. Not all of them have 8 electrons in the outer shell, so that's why I revised what I said earlier in accordance to what the syllabus said. The number of occupied electron shells is equal to the period number. So period is the horizontal bit. So going horizontally, okay, how many electron shells have been occupied? This is period 1, okay, so this is period 1. And then this is period 2, because it's the second row, right? This is period 3. Okay, this is also period 3. This is period 2. This is period 3, and so on and so forth. At the very least, you need to know the first 20 elements. It's a lot easier if you actually remember the elements as well as their symbol. So the confusing one includes sodium. A lot of students will have thought it's SO, but it's actually Na. And things like sulfur is not Su, but it's S, and the other elements have their specific symbols. If you know the symbol, is a lot better, and it will help you with constructing chemical formula at the later stage as well. All right. So yeah, the number of occupied electron shell is equal to the period number. So if you are in the period 2, that means you have 2 occupied electron shell. If you're in period 3, you have 3 occupied electron shells. All right. If you're in period 1, you have only 1 occupied electron shells. So very straightforward there. State. Okay. So these are part of the learning objective. The candidate should be able to. If you are not able to do whatever each and respective bit that the syllabus say you must be able to do, then you will be in deep trouble, because everything that is asked will be from the syllabus. Let's get started. I talked earlier about electronic structures. Is to do with how the electrons are filling in the shells, or how the electrons are arranged in the electron shells. And electrons are orbiting around the nucleus. As you know, the nucleus has the proton and the neutrons. They make up the majority of the mass. They make up the majority of the mass of the atom. Okay, the first shell, maximum 2 electrons. Electrons are negatively charged, as we talk about the relative charges and the relative masses in the previous subtopic. 8 electrons. In the third shell, for simple analysis, at least up to element 20. Okay, up to the element 20, we can say, well, actually not up to element 20, I guess. Actually, I can, yeah, okay. So maximum 8 electrons, okay. In reality, when you go to A levels or the sixth form, this is not really true, but you know, for simple analysis, at least in O level or IGCSE or GCSE level, is enough to be happy with a maximum 8 electrons, because otherwise we will be incorporating a more difficult concept that you will get to revisit if you go on and do chemistry at a more advanced level. All right, so that's why it's important that it's being remarked it's only for simple analysis up to element 20. That's up to calcium. We talk about the third shell, maximum 8 electrons, but we need to be careful. Element 20 is actually in the 4th period. Okay, so just be aware of it. All right, so this is how we represent the electrons filling in the electron shells. We have the nucleus. The nucleus is represented at the center of an atom with the number of protons and neutrons. And then we have the first shell with 2 electrons, the second shell with 8 electrons, but the third shell only has 1, 2, 3, 4, 5, 6. It is 2 electrons short of the maximum 8 electrons, and that is because sulfur, if we look at sulfur, that is element S. I don't want to go that way. I want to go to the periodic table. So we have sulfur here. Okay, so we are going to use the periodic table to help us indicate what it is. All right, so first of all, it's in group 6. This is Roman numeral for 6. So that means sulfur has 6 electrons in the valence shell. All right, that's the first information. 6 electrons in the outermost shell or the valence shell. Second information is this is the first period. This is period 2, second period. This is the third period. So it is filled up to 3 electron shells, and the outermost shell is the third outermost shell, because the first shell will fill 1 electron, 2 electrons maximum in the first shell. The second shell, which means the period 2, will fill up to 1, 2, 3, 4, 5, 6, 7, 8. Second shell fill up to 8 electrons. So from the first shell 2 plus 8, you will have 10 electrons. So it's like playing a snake ladder game. You are now at neon, you want to get to sulfur. 10 electrons ready. Now you are filling in a new shell, that's why it's a new period. 1, 2, 3, 4, 5, 6 electrons. Group 6, 6 electrons in the outermost shell. So that's how you make use of periodic table. Look at the period number. It tells you it's the first shell, second shell, and the third shell. So it has up to 3 shells that are being occupied. It's in group number is the vertical alignment. It's in group 6, VI stand for 6, so there are 6 outermost shell electrons. There are first shell, second shell, and third shell. Remember, from hydrogen to helium, and then all the way from lithium all the way to neon, 8 electrons. And then it's in group 6. Group 6 meaning 6 outer shell electrons. Therefore 1, 2, 3, 4, 5, 6. The next question that a lot of students ask is, does it matter if I have them like this, or does it matter if I put them 2, 2, and then this other one here and here? It doesn't matter, because to be honest, your electrons are not static. They are always orbiting around the nucleus. That is, the electrons are always moving, right? So at that one moment in time, your electrons could be here, 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 or here. As long as you have the correct number of outer shell electrons, you would have been fine. It's just that most textbook and most revision notes, whatever, they always show them as pairs. But even these, when there are 2 of them, there's no way of telling it that it's this here at this moment in time, because they are always orbiting around the nucleus. Alright, so based on what I said, this is essentially what has been going on. Looking at the periodic table, your sulfur would appear as 16 and 32. Okay, so I'm going to show you something which is very, very confusing. This is 16 and 32. This is from periodic table. So it is really confusing because your periodic table shows you sulfur. 16 on top is the atomic number. In the previous subtopic, when I went through the lectorial, I talked about atomic number being the number of protons in the nucleus of an atom. And then the bottom bit is what you call the mass number. In reality, it's not really the mass number, it's the related atomic mass, but that's why you call it the mass number or the nucleon number. Okay, but if you look carefully, this is a different way of representing it. Okay, when we, meaning you, okay, meaning you, when you write, you have to write it in this format, which is 3216 sulfur. This is the accepted norm. Right, so these are written on the far left. Okay, so the important bit is, the top bit is the mass number or nucleon number, and then the bottom bit is the proton number or the atomic number. Going forward, whenever you see questions in a Cambridge exam, it will always appear in this form. Okay, this is from the periodic table, okay, not how we or you would write. So if you have to write on paper, you will write something like this, where you have the proton number on the bottom left, okay, not in the middle, because that is what you are given. But when you write it in this form where the proton number is at the bottom. But you need to be careful when you look at the periodic table, because periodic table is already fixed and it's been given to you. The atomic number, meaning the proton number, where the number keep on increasing by 1, okay, because that's how the periodic table are filled. The proton number is 16 and not this number at the bottom, because this is how the periodic table are given. Okay, see what I meant by how confusing it is. They provide a periodic table like this, even in A levels. Cambridge exams also provide like this, but how you normally write to represent an atom is always in this particular format. internationally, everyone accepts it in this particular format. Proton number like this at the bottom left, mass number or nuclear number on the bottom top left, and then the symbol of the element. They are not in the middle, not like in your periodic table, and they are not in the same order as given in your periodic table. Be very careful, yeah. So looking at this, there are 16 protons. That's why there are 16 protons. You have 32 nucleon. Nucleon number tells you the number of nucleons in the nucleus of an atom. So nucleon is the number of protons and neutrons. If you know the number of protons, you can work out the number of neutrons. So therefore, when we look at 32, 16 sulfur, we can write down protons, electrons, and neutrons. So there are 16 protons because the proton number is 16. This is how we represent it. The neutron number is 32 minus 16 because nucleon number is the number of protons and neutrons. Definition, definition, definition as stated in the previous syllabus. Candidates should be able to. Alright. Now the difficult bit here really is looking at the electrons. The electrons will be 16 as well because we are looking at an atom. An atom has no overall charge. Okay. When they say no overall charge, they also sometimes says electrically. I think that's the correct term that they use in question, electrically neutral. But I like this thing better, no overall charge. So an atom has no overall charge. So neutron memang has no charge. Sorry, I just used Malay language, but anyway. Neutrons have no charge. So protons are positively charged, electrons are negatively charged. So if you have an atom which has no overall charge, your number of electrons have to be equal to the number of protons. Alright? Definitions of electron shell or energy level. As I said, it is not a physical shell, but it's simply where you have a highest probability of finding the electrons, and the electrons are always moving. That is what I meant by you can always show it as 2 electrons here, and as long as you have 6 electrons in the outer shell, for a group 6 element, you would be alright. Okay? So you're gonna have to spend some time to practice drawing on another piece of paper in a similar format like this, using the circle format to show the filling of the electrons in each particular shell, knowing that the first shell fill up maximum 2 electrons, second shell add electrons, and third shells fill up to add electrons maximum as well. You have to do it for the first 20 elements. And as you can see, the first shell filled with 2 electrons maximum. Then you are here. Your snake ladder game tells you that you fill a new period. So this is a new shell. Fill up to 1, 2, 3, 4, 5, 6, 7, 8. So add electrons maximum in the second period, in the second shell. Then you have to fill in a new shell. That means you're in the third shell now. This is your outermost shell. It's got 1 electron in the outer shell. 2, 3, 4, 5, 6, 7, 8. So all of the noble gases have fully filled out the shell. Then you fill in period 4. So this is the 4th shell with 1 electron in the outer shell. 4th shell with 2 electrons in the outermost shell. And according to the syllabus, you can stop there. Okay, because you need to know the electronic configuration on how the electrons fill up the 1st, 2nd, 3rd, and the 4th shell up to element 20. Alright. So I'll show you a couple of examples, but I probably wouldn't go through all of these. You can show them on your own. The first element is hydrogen. So I can write hydrogen there. And then I will have, perhaps I can draw a better circle like that. And of course I can, because I'm doing this on the screen, so it looks nice and easy. If you're doing this on a paper, don't spend too much time on getting the perfect circle, yeah, because at the end of the day, you just want to be neat in your writing. First shell, 1 electrons. Hydrogen, because it has got 1 proton, and it has got 1 electron, because it's an atom. An atom has no overall charge, because atom has no overall charge, so the number of proton equal to number of electrons. This is my summary, but in words you will say this thing, therefore the number of protons is equal to the number of electrons. What I'm saying is, whenever I use abbreviations, you're not allowed to use abbreviation in the real exams. You have to outline them in words. Okay, in other sense, the positive charge of the protons balance out the negative charge of the electrons. That's why an atom has no charge. Okay, this is an atom. Okay, this is an atom. It is not H2 molecule. Previously, we talked about atoms, molecules, compound, and mixture. So you gotta remember that atom is not molecule. Even though that elements can exist as molecules or atoms, but we are talking about atomic structure. We're talking about individual hydrogen atom. We're not talking about hydrogen as a molecule. All right. So going on to the next one, you don't need to write all of these for all the practice questions, but you need to practice drawing the circles, and you need to put in the correct electrons. So you can draw like this. As I said, the electrons are always moving, but you see that there's nothing wrong with this apart from the electrons are always moving. This is an electron shells, all right. However, so most books will typically show you that the electrons are staying far apart from each other, because obviously electrons are negatively charged, so ideally you don't want to put them so close to each other. All right. So the electronic configuration of hydrogen is just 1. The electronic configuration is just 2. Okay, so you would just write the electronic configuration is 1 and 2. 2 electrons in the outer shell, 2 electrons in the valence shell, and only one electron shells, because this is a period 1, and then 2 electrons in the valence shell, but this is group 7, because we are talking about noble gases, and helium is one of the noble gas that has only 2 electrons in the valence shell, because you only have 2 electrons to begin with. All right, you have 2 protons and therefore 2 electrons in an atom of helium. All right, going very quickly onto lithium, so you can do the rest on your own. Really, I probably wouldn't have time to go through all of them individually. So lithium, the first shell fills up with 2 electrons, so now you're at hydrogen helium, because you already have 2 electrons in the first shell. So now you need to fill in the next shell. That means 1 electrons, and we have altogether, if you look carefully at lithium, the periodic table, to go to lithium you need 2 electrons in the first shell. Lithium is in the second shell because it's the second period, and it's group 1. 1 outer shell electrons, 2 period, 2 shells that are being filled, first shell, second shell. All right, so the configuration, I can improve my handwriting a little bit more. The electronic configuration is 2 1. Okay, so what does the 2 1 represent? 2 comma 1. So this is the first shell, this is the second shell. Okay, this is the valence shell, the outermost shell, because it's the last one to be filled. You fill in a shell first, and then there are 1 valence electrons, therefore group 1. Roman numeral, not the normal numeral 1, but Roman numeral 1. 2 electrons in the first shell, 1 electron in the second shell, total 3 electrons. Okay, we can continue the rest. Let me just show you a couple more. So beryllium is group 2, period 2. So we know there are 2 electron shells occupied. They are not completely filled, but they are occupied, and this one means there are 2 valence electrons. And I can talk about beryllium, the first shell, 1 2, and then the second shell, again 1 2. I have just simply moved them further apart because usually we talk about electrons being negatively charged. They don't want to be next to each other. But when you look back at some examples such as these, they always put the two together just to make them look nice. In reality, let me emphasize, the electrons are most likely to found in this region of space called electron shells. Electrons are always moving. It's not static in one place. If they're repelled, they don't like to be too next to each other. They will move away, but still in this region of space. And what you see here is a two-dimensional diagram. In reality, it's not a circle, it's a sphere because, things are in three dimension, so the electrons are actually orbiting in three dimension and not just in this two-dimensional circle. All right, so you can continue the rest of them. So beryllium would be 2 2. So what can you interpret from there? 4 electrons total. This is the first shell, this is the second shell. The first shell is filled first, so you fill up to second period or period 2, and there are 2 valence electrons in the second shell because you fill up to the second period, and so on and so forth. I'll probably show you one more example, and then maybe 2 more examples. Okay, so you should do it for the rest of the periodic table up to element 20. But I'll show you, let's say, for chlorine, and I'll show you another one for potassium as well. Okay, and then I'll call it a day for this lectorial. So chlorine in the periodic table is element number 17. Okay, and then this is element 17. The way we write it, this is proton number. Notice that I skipped the nucleon number because we can have chlorine 35, which is not 35.5. Your periodic table show you 35.5 and 17. This is relative atomic mass. In reality, relative atomic mass is not the exact. Relative atomic mass is not the exact number of nucleon. It's to do with a definition that we will cover in the next lectorial video. So what do we have? We have 17 proton. We will have 35 minus 17 equal to 18 neutron. We will have 17 electron because we are talking about an atom, so no overall charge. We are talking about electronic configuration. So if you look carefully at chlorine is this, is the third period, first period, second period, third period. Okay, first period, second period, third period. This is group 7, so it's got 7 outer shell electrons, but that's because it fills 1 and 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 electron in the second shell, 1, 2, 3, 4, 5, 6, 7 in the third shell. Okay, so very straightforward there. Looking at the periodic table, you can tell 2 electrons in the first shell, 8 electrons in the second shell. You will go up to neon. Then your snake ladder tells you need to go from sodium all the way to chlorine. That is 7. So when you draw it, you can start by drawing like that. 1, 2, second shell. Of course, it's easier to draw on a screen where I can draw the circle to be quite perfect to each other. But you need a bit of a practice in order to draw quite a good circle. You don't want a circle that looks really bad, so that looks quite bad as well. Okay, but at the same time, you don't need a compass set in order to draw a perfect, well, not perfect, but a decent looking circle. And let me just highlight the point. You gotta check 2 electrons. Okay, 1, 2, 3, 4, 5, 6, 7, 8 electron in the second shell. 1, 2, 3, 4, 5, 6, 7 electron in the third shell. Yeah, altogether 8 plus 10, 8 plus 2 is 10, plus 7 is 17 electrons overall. This is electronic configuration. First shell, second shell, third shell. Third shell because it's period 3, 7 because it's group 7 according to the periodic table. Okay, group 7, period 1, 2, and 3. Finally, I should look at potassium, period 4, and it's in group 1, so it has got 1 electron in the outer shell in the 4th period. After it filled in 2 electrons, 8 electrons and 8 electrons, it will have 1 more electrons there. There is 19 proton because your periodic table show you proton number on top, but when you write it out, we always write them as 19 as the proton number on the far bottom left, not in the center like periodic table, but at the bottom left, and the top left is the nucleon number, or what you call the mass number. Okay, so we know it's going to be 2881 because you fill up to helium, and then you go from lithium all the way to neon, and then you go from sodium all the way to argon, and then you go to element number 19. Element number 19 is in the group 1, so 1 electrons in the outermost shell. This is the fourth shell. This is the first. This is the second. This is the third. The fourth shell is valence. There's 1 valence electrons. 2 plus 8 plus 8 plus 1. Total 19 electrons because this is an atom. Alright, so what we have then is I can write K, and I can start drawing the first shell. The second shell has got 8 electrons, and then the third shell. Oh, you see, it's all nice and good on my screen, but it's not going to be easy on your paper unless you start practicing a little bit more. Okay, so that is not really good looking, but that's probably like what I could do to minimize the time for this video. 2, 8, 8, and 1. As I said, you can have the cross further apart, and it really doesn't matter because the electrons are always moving, because these electron shells are not physical, they are just region of space. In fact, they are in 3-dimensional and not in a circle like this. 3-dimensional is a sphere, is always moving along this region of space where the electrons are most likely to be found. Okay. So continuing on to what we have learned about the groups and the periods, I told you that the Roman numerals stand for the group number. It basically is to do with the vertical section of the periodic table. The Arabic numerals, 1 all the way to 1, 2, 3, 4, 5, these are what we use to represent period number, or sometimes they just call it the first, the second, the third, the fourth, etc. period. Alright, so elements in the same group, when you are in the same group, you have the same group number, therefore you have the same number of valence electrons, and that is very common sense. Based on what we say, the group number tells you the number of outer shell electrons or valence electrons. So for example, group 8 elements, noble gas, would have a fully filled outer shell apart from helium, because helium is occupying the first shell, so there's only 2 outer shell electrons. Always something that Cambridge likes to catch students out, because they are not careful, they don't read or understand the periodic table completely. The period number tells you the number of occupied electron shells, as I said earlier, and that was at least true for the first 20 elements as some sort of simplification, especially for potassium and calcium, which is in the 4th period. So this is just a table, just outlining how you can process those information after you've done the practice for the first 20 elements, the electronic configuration. Alright, so potassium, if with a periodic table in front of you, and we already did it before, 2881. So it's in the 4th period, and there is 1 outer shell electron, so it's group 1, and it's in the 4th period, so you occupy the 1st, the 2nd, the 3rd, and the 4th shell. Fluorine occupies up to the 2nd shell, the 1st and the 2nd, so the period number is 2, and the group number depends on the outer shell electrons, so there are 7 outer shell electrons. Alright, so chlorine occupies period number 3 because it filled the first shell with 2 electrons, 2nd shell with 8 electrons, 3rd shell with 7 outer shell electrons, that's why it's group 7. Oxygen is group 6 and it's in period 2. If you have a look at the periodic table, that will be 2 and 6 because it's in group 6. It occupies the 2nd shell, so 1st shell, 2nd shell. Alright. So sulfur, this is actually incorrect. Sulfur should be period 6, but it should be period 3, so it's actually 286. And sulfur being 286, that was what we said earlier. This is 2, 8. And then 1, 2, 3, 4, 5, 6, 3rd period, group 6, 6 outer shell electrons for sulfur. and I can go on and fill up the rest. This is group 2 and it's period 2. So we're looking at the second row of the periodic table, and it's group 2, so it's 2 outer shell electrons. This has got to be beryllium, 2 and 2. This is group 5. Okay, so you're looking at group 5 and you're looking at period 2 again. Group 5 and period 2. Group 5, this is period 1. Okay, but this is period 2, group 5. There's nitrogen, so it's 2, 2, 5. All right. So 2 electrons in the first shell, 5 electrons in the second shell. This is nitrogen. This is element number 7. All right. This is group 6. This has got 6 valence electrons, and this is period 3. So we should be looking at something which is below oxygen. So this is actually sulfur again. This is 286. All right. So that was my mistake. It's a repeat of the other one apparently. Okay, maybe if I kept this as 5, it will be 285, and it will be phosphorus instead, for example. Yeah, so maybe I can write that down as phosphorus. Then there will be 285, and this one will be correct. Okay, helium is just 2. It's helium is not group 2, but helium is group 8, being noble gas. It's in the first period. Neon is second period, argon is third period. Helium, neon, argon, they are all from the noble gases. They all have fully filled outer shell, as you would have known from your lower secondary chemistry or lower secondary sciences. All right, so that's the end of this tutorial video, lectorial, specifically on electronic configuration as part of atomic structure, which is a big topic. Yeah, so thank you for watching, and I'll see you in the next video. If you got any questions, raise up as comments, or come find me. If you are students from my school or from my class, just come find me and ask me any questions you have. All right, so thank you for watching again. I'll see you in the next video.